Welcome back, everybody. 2.5, calling a non-void method. Our learning objective, we want to call non-static, non-void methods with or without parameters. We have one topic today, calling a non-void method. Our learning objective, call non-static, non-void methods with or without parameters. So let's imagine for a moment that you are going out to a fancy restaurant for a fancy dinner. We know it's a fancy restaurant because they bring you bread to the table before you even get your food. And so when your waiter brings you your food, you have some options of what that waiter can do with that food. The waiter can post a picture of your meal on social media. That waiter can eat your meal for you. The waiter can split your meal with someone else. Or the waiter can give you your food and let you decide. It doesn't seem like too confusing of a choice, right? You want the waiter to just bring you your food and you will decide what you want to do with that food. If you want to post a picture of it, you can do it. If you want to split it with somebody, you can do that as well. The only confusing thing is what is Mr. G going to do with that fork and that knife? It's a veggie burger and fries. So we can think about this the same way that we think about a method. The user is going to supply some input into our method, and in most cases, they're just going to want the method to give the output right back to them. You typically don't want the method writing information to the console for the end user to see because you want to take that data. Maybe you want to change that data, or maybe you want to format it a different way before the user sees it, or maybe you want to do something else entirely with that data. It should be up to you. This is the same as when you place an order in a restaurant, it goes to the server, and then you just want the server to bring you your food. So we will be looking at our two remaining category of methods, methods that return results, and we're going to look at some that don't accept parameters and some that do accept parameters. So the main focus on this is that we are looking for non-void methods. So we have two examples of methods up here. The first one we saw already, it's a void method. It doesn't return any data to the user. So that's going to do something like print some information to the screen. We want to look at non-void methods. So where that return type is, we want to see a data type here instead of the word void. So a non-void method is a method that has a return type and returns a value to the calling code. So the second example will give some data back to us, and it is going to be data of type int. That's what this return type up here indicates. In order for something to be a non-void method, not only does it have to have a return type up here, it also needs to have a return statement inside of its algorithm. The return statement is a statement that causes a method to end, and this is how we send back the information to the calling code. So this method is still going to calculate a result, but instead of putting it out to the screen, we are just going to return that result to whoever is using this method, and they can decide what to do with that information. So all non-void functions must have a return statement, that keyword return followed by some data to return, and it must be the last line in the method because the method won't do anything after it returns some data because its whole point is to return some data. So there's no need for it to process any more code after that return statement. So here we can see a void method and a non-void method side by side. The big difference shows up on line 1 in both sets of code. On the left, we have a return type of void, meaning we are not giving any data back. On the right, we have a return type of int, which means that we are going to return an integer value. They're both called calc area, and they both have a formal parameter list. So non-void methods can have parameters, and non-void methods cannot have parameters. They both have different algorithms. The void method is still calculating the area, but it's displaying it to the screen, where the non-void method on the right calculates the area, stores it in an integer variable named area, and then returns that value back to the calling code. So if we look at the signatures of these two methods, on the left, we have calc area int int. On the right, we have calc area int int as well. So these are the same signatures. The return type is not featured in the signature. So these are not unique. We cannot have both of these in the same method. Because if you are calling a method called calcarea and giving it an int and an int, Java doesn't know if you want to call the one that should return data or if you should call the one that doesn't return data. Oh, we already just looked at signatures. Hey, it's no problem. No problem at all. So a non-void method is going to return a value. It's going to throw something back to the calling code. There are three things that we can do with that returned value. We can drop that returned value, we can catch that returned value, or we can catch that value and pass it on. We're going to look at examples of all three. So on the right-hand side, we have our class rect. It has one method, calculate area, where accepts a double and a width. Now this is a non-void method because it has a return type of double in the front. It doesn't say void anymore. So it's going to accept two doubles and give one double back. A non-void method can only return one value. So it's going to calculate that area, and then it's going to return that area back. On the top left, we have an example of where we drop that returned value. So you can see we are declaring a rectangle named R1. We are setting it equal to the memory address returned when we called the constructor with no parameters. On line 5, we are calling that non-void method. We are passing in two actual parameters, a double literal of 3.0 and a double literal of 2.5. This whole statement is going to evaluate to 7.5. So that is going to turn to a 7.5. But we don't do anything with that 7.5. We're not putting it into a variable. We're not printing it out. So then it just kind of goes away. We're just dropping the value. So dropping the value isn't a good thing. If you're going to call the method and ask for an answer, you should do something with that answer. So the second one is an example of where we catch that value. That's what we're going to want to do with it. We're doing the same thing. We're still declaring and instantiating a rectangle object. We are still calling that non-void method. We are still passing in two actual parameters. So now everything to the right of the assignment statement is going to evaluate to a 7.5. And that's going to happen first because this dot operator has a high precedence. It has a way higher precedence than the assignment operator. This expression on the right-hand side will evaluate to a 7.5, and now we are going to assign that to stack memory to a place that we are labeling ANS. Notice when we declared our variable, we made it of type double, which is the same as the return type of the method. It's going to give us back a double, so we need to have a double to put it in. And then we could do whatever we want with that. In this case, we are just printing out that answer. But any line after line 5, we can use ANS and work with that answer that was given back to us. Our last example is where we pass that value along. And that's another acceptable thing that we can do when we call a non-void method. Begins the same with our object declaration and instantiation statement. We have our call to the non-void method with parameters. So remember, that's going to evaluate to a 7.5. Once that evaluates to a 7.5, we are just going to pass that right into the print line. And so that's just going to print it right to the screen. So we are doing something with that value. We're giving it to another method. We are not capturing that value, so we won't be able to use that answer anywhere after line 5, but we did something with the answer that we got. That aligns with our essential knowledge. Non-void methods return a value that is the same type as the return type in the signature. To use the returned value when calling a non-void method, it must be stored in a variable or used as part of an expression. So here we have a couple of extensions of catching a returned value and passing along a returned value. We're going to take a look at our rectangle class on the right-hand side. We still have a non-void method. It is still returning a type of double, but this one is not accepting parameters. So a non-void method can accept parameters or it doesn't need to accept parameters. So this one is not accepting parameters. It is just going to use the member variables width and height to calculate an area and return that area. So in our example on the top left, we are declaring and instantiating three rectangle objects, R1, R2, and R3. And we are passing in some actual parameters for those widths and heights. So we're passing in two doubles for both of them. That goes into the constructor to construct those objects. So on line 7, we have an expression that has multiple calls to that non-void method. Each one of these will evaluate to a value. The dot operator has a higher precedence than our addition operator. So all three of these will evaluate to whatever value is returned by the method. And then we will add up those three answers and we will store the answer in total area and then we'll print out total area. So after line 7, we won't have access to any of the individual areas. We would just know the total area because we'd never captured each one individually. We just captured the addition of all three of them. We could always call r1.getArea again anytime that we needed to. Our second example is the pass and pass. Looking at line 5, we have a bunch of parentheses. We work at the innermost group of parentheses, which we are calling r1.getArea. That is our non-void method that calculates the area and returns the area. So this is going to evaluate to a double value, and we are immediately passing that into the square root method from the math class. That's going to find the square root of that answer, and we're immediately passing that result into the print line. So you can continue to pass results into other methods if you want. A common non-void method will retrieve the value of member variables in an effort to stop the user from directly accessing those variables. So we have a geometry class, and in our geometry class, we have three variables, a width and a height and a radius. Now, we don't want the user directly accessing these because we don't want them putting in values that don't make sense. So in a previous lesson, we saw that we can create setter methods so that we can check the values before we put them in there. Well, if we're going to make setter methods to put the values in there, we should also make getter methods to get the values from those variables and return them to the user. So you can see those getter methods down in our methods section. They are non-void methods. They have a return type of double. Getter methods usually start with the word get and the name of the variable that you are returning, and it just returns that member variable. So we have our get width that just returns the width, we have our get height that returns the height, and the get radius that returns the radius. Getter methods usually don't have parameters because the user doesn't need to tell us any more information. They either want to get the width, the height, or the radius. So let's wait for it. Oh, I guess he's not going to come and ask us for the signatures. Looking at those three signatures on line 17, 21, and 26, they are all unique because they all have different names. I kind of miss him now that he didn't show up. That's going to end this one. Make sure you rate how you feel on that learning objective. Make sure that you hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.